The same cement resistance 10 ohms measured using a 2-wire system has a value of 9.48 ohms. The 4-wire system measured 9.40 ohms. Which of these two values is more accurate? The answer is that measuring resistance with a 4-wire system is closer to the true value of resistance. Today, we will unlock the ultimate solution for precision measurement, the 4-wire method for measuring resistance. After reading it, you will know why it can eliminate errors and become the gold standard for small resistance measurement. We usually use the 2-wire method to measure resistance, and the principle is very simple. A multimeter outputs a current, then measures the voltage across the resistance, and calculates the resistance using Ohm's law, but this introduces the line resistance of red and black probes. Even copper wires with excellent conductivity still have line resistance. These two resistors will be connected in series with the measured resistor, and the multimeter will actually measure the total resistance. Therefore, when we measure small resistance and large line resistance, the error in the measured resistance value will be significant, which is the fatal problem of the 2-wire method for measuring small resistance. The key advantage of the 4-wire system for measuring resistance revolves around the separate measurement of current and voltage. This design can accurately avoid interference from tested lead resistance, and the underlying principles can be interpreted from two aspects: Ohm's law and voltmeter characteristics. According to Ohm's law, when a test current flows to a certain test node, if there are two flow paths, the current will preferentially choose the path with lower resistance. In the 4-wire measurement architecture, the system injects test current into the measured resistor through two leads current lines. At this time, the main path of the current is current line measured resistor, because the core resistance of this path is the measured resistor, and the value is relatively small. Looking at the application logic of the voltmeter again, the fundamental reason why the voltmeter must be connected in parallel at both ends of the measured object is that it has a very high internal resistance. The fundamental reason is that it has a great internal resistance. This feature can minimize its impact on the original tested circuit. The internal resistance of a conventional voltmeter usually reaches several tens of megaohms, and some with better performance can even reach 10 ohms. The resistance measured by the 4-wire system is often less than 1 kilo. Due to the fact that the resistance of the voltmeter measurement line branch is much greater than that of the current line measured resistance main path, according to Ohm's law, the current in the voltmeter branch will be so small that it can be ignored. When there is almost no current in this branch, the resistance of the measuring line itself will not produce a voltage drop. At this time, the voltage measured by the voltmeter is the true voltage at both ends of the measured resistor. This design that separates emitting current from measuring voltage brings significant advantages. The line resistance of the 4 red and black probes will not be involved in the final resistance calculation, ensuring the accuracy of the measurement. When wiring, the input current wire should be connected to the outside of the resistor, and the sense voltage wire must be tightly attached to the pins on both ends of the resistor. This wiring will make the measurement more accurate. We switched the function of the multimeter to the 4W omega mode, and the 4W symbol was displayed in the upper left corner of the screen. Manually select the range to avoid slowing down the speed due to automatic range selection. To improve anti-interference, adjust MPLC to 100, but this will sacrifice measurement speed. Principle: the smaller the measured resistance, higher the accuracy requirement, the more the 4-wire method should be used. Measuring high resistance such as megaohm level can be done using the 2-wire method, and the error can be ignored.